Hi, I'm Josh Paulison. What is the slowest part of working in Unity that affects the entire team? That would generally be when you hit the play button. Now, as you can see, I have next to nothing in this game, and it still takes time to start up. And if you're having to rapidly change, for example, an enemy, and you have to keep restarting, you're losing a lot of time. I'm going to start by just talking about this enemy manager over here. So this is a pretty common paradigm that is allowing us to track all of the enemies, and it is also allowing us to associate each enemy with what we're calling here design data. Every time that an enemy is created, it has to go through here. It has to go through this manager. You can see there's a static method. That means you can call it from anywhere, and you end up passing along a GUID. Then you're looking through all of your design data that's available, and you are creating a new enemy by it. Now, what do these templates look like? Well, they're actually JSON files that are stored elsewhere in the project. And here's an example of one of them. GUID, basic movement 00. That's not really a GUID, but don't worry about that for now. And then we've got a series of actions. And this action is add speed, and it has an argument of 1. Whoa, look at how slow it's going. I want to change that. I might have to stop, alter prefab, or alter a script depending on your setup, and we don't really want to waste time doing that. What can we do instead? Well, I can set this to 5 here, and I'm going to reload the assets. This is not a script, this is JSON. I'm going to hit the spacebar, and you're going to see that it's moving faster now. What if I want to add something else to this? What if I want to add another action? So for example, action rotate, and then args, and let's set this to 180. Now, if I reload this, you're going to see that it's just going to shoot that way. And I don't want it to do that immediately, actually. I want it to wait for a little bit. Action wait, args 1, that's going to be 1 second. Now let's see here. You can see it bounces back and forth. I can extend this a little bit by going action go 2, and I can pass along an arg, position index 1. See it bounce back and forth and back and forth. I haven't had to restart the game at all, and here I am able to adjust the feel of an enemy on the fly. In this case, it's a bunch of actions. In your case, it might not be actions. It might be that you have items and you just want to change some stats on them. It could be that all of your enemies have the same logic, but their speed changes, and their size changes, and their color changes, in which case, hey, you don't have to have a series of actions here. You can just have speed 10, size 2, whatever different stats that you want. Now, where are these actually being set up? When an enemy is created, it ends up passing along this design data. I've heard the term templates. I've heard different terms used for this. In this case, if we end up jumping into here, it's just creating an instance. Very simple helper method here. We're loading a game object, creating it, getting this basic component off of it, our enemy component off of this prefab instance, and we are setting it up with our template. Again, you can see some of the code. It's like, why is this underscore not that? This is pretty early code, but I still wanted to show the concept. And so now we've got a design data associated. And when we run this logic, we're running enemy actions based on that template. Now, why do we care about this at all? Why do we have this design data that is not part of the enemy data directly? Instead, it's pointing to an instance of a class. This isn't a struct, this is a class. And so if you have 100 enemies using the same design data, they're all actually pointing to the same instance. And we save a lot of data. They're all just pointing to the shared logic. And so rather than having 100 different enemies that have this data copied across every single one of them, we've got 100 enemies all pointing to the same data. And if we start having fun with the manager, we can do things like reload templates on all the enemies. It can reference all of the enemies, it can check what template ID they used to have, and so you can end up reloading the assets, see what template ID an enemy used to have, and load the new updated template over that same enemy, and so you can have their logic update on the fly. And you can do a lot of things like this that just make testing so much easier. As I said, as your project progresses, it is going to become slower and slower to stop and restart Unity. And it can be a big pain point for everyone on the team. Designers especially just need to make sure that it feels good, right? And that can take a lot of tweaking, that can take a lot of polish, and if you're having to stop and restart Unity all the time, that adds up a lot. So this is a very, very simple introduction to this concept. Let me know if you're interested in hearing more about it. It's one of those things that doesn't feel revolutionary unless you haven't seen it before. And then it's like, why haven't I been doing this? I was losing my love of programming, and once I was taught this approach, I was like, this is why it sucked. This is why. Why was I doing that? And usually it's just that there aren't people teaching that. This is early code. Feel free to critique it in the comments. There's a lot of stuff that I'm probably going to be changing already, maybe things that you're already noticing, but I hope that this helps with giving you some new ideas on ways that you can optimize your game workflow. Thanks so much for watching. Take care.